In this video, we have two parallel plates next to each other with a delta V of 15 volts. And we're going to solve for the separation distance of these plates if we have an electron that's being accelerated at a rate of 1.76 times 10 to the 14th meters per second squared. So the first thing we're going to do is go ahead and use that acceleration along with some known variables. And we can use acceleration equals force over mass. And we're going to substitute in QE for the force. And then from there, we'll be able to solve for the electric field because the mass and the charge for an electron are known constants. So what I did was I plugged in the magnitude of the Q value for an electron. Normally it'd be negative, but I just put in 1.6 times 10 to the negative 19th so that I'd find the magnitude of the electric field. And then we have the known mass of an electron, 9.11 times 10 to the negative 31st. I did a little cross multiplying. I brought the mass up next to the acceleration, multiplied those two, and then divided them by the Q value by dropping that right below. And I have an electric field of 1002 newtons per coulomb. Now from there, I know that the electric field equals delta V over R. So from there, we don't have too much more to do. We're just going to plug in our electric field, our delta V, and then we can go ahead and solve for our R value. So we put in our delta V of the two parallel plates as 15 volts and the electric field that we just found. Again, did a little bit of cross multiplication and then had the R and the electric field switch spots. So then we did 15 divided by 1002, and then we got our separation distance of 0.012 meters. And that's our final answer. So to sum things up, we have an electric field that goes from left to right, which would mean that the actual velocity of the electron would be opposite of the electric field. It would be attracted to the positive plate there. And as it gets pushed out, it has an acceleration of 1.76 times 10 to the 14th meters per second squared. Once we took Newton's second law and subbed in the QE for the F, we were able to solve for the E value. And then from there, it was a final simple calculation where we set the electric field equal to delta V over R. Plugged in our delta V, cross multiplied right over here, and then we finished off with a final separation distance of 0.012 meters between those plates. So I hope that was helpful to you. Thank you for watching and listening.